Welcome. This is our fourth video about histograms, and in this video we're going to use some common words to discuss the shape and visual aspects of a histogram, and then we're just going to look at a few examples and discuss and use those words in relationship to the examples. So the first remark here is just kind of about what histograms are even for. And it's giving us an immediate visual summary of the distribution. So you kind of get a good picture in your mind visually of how the individuals in your sample or population are spread out among the different values of the numerical variable. So the histogram that shows the heights of people on a basketball team will be different than the histogram that shows the heights of people just in a math class. And you'll get to see that spread, and it'll carry more information than just saying what the average height is on the team or the average height of the individuals in the classroom. So some common shapes deserve common naming schemes. So symmetric just means there's kind of a clear middle, and then there's equal amounts to the left and right. And like if you view the histogram as a cityscape, there's like where the towers represent, where the bars are representing buildings, then there's like a clear middle of the city, and then to the left and the right of that city center you still have tall buildings, but they're going and they'll get smaller, but they go out equally on both sides. Skewed left and skewed right is more about an asymmetry. So there will be some height and then a kind where the bulk of the data falls, and then there'll be kind of a decreasing expression of values as you get farther away from the height. This example that you can see at the bottom is skewed right. And it can be hard to remember because you see all the data on the left and you want to use the word that describes, you want to say skewed left because that's where all the data is, but this is skewed right. And we'll talk more about why that is in the next video. This next definition is for the word mode, and it's a value of the variable for which there is a relatively large amount of representation in the distribution. So you don't have to have a mode, but when you have some value where a lot of the individuals in your study take that value or their set of values, that would be called a mode. And it's just a relative peak. It doesn't have to be the highest one. And you don't say the mode is the number of individuals taking it. So for instance, here on the bottom, the mode is not 100. The mode is the value, so between 0 and 5. The mode is another statistic like average. You wouldn't say the average is the number of individuals who meet the criteria. You say the average has something to do with the numerical variable. Another definition, outlier, is a piece of data that's extreme. It's somehow far away from the other ones. And we'll get more technical about that in future units. But right now we can just ask, why is it important to identify outliers? And one reason is they are interesting because they're different. Two, they may indicate an error in your data collection. Like they might be an extreme value just because you measured wrong. All right, well, so let's look at this histogram. And first things first is kind of just figure out what we're looking at. So the title, number of guns per 100 people for 230 counties and countries and territories. And then we're counting, so we don't have relative frequency, we have actual frequency. And this is a number of countries or territories. And then the variable that we're measuring is guns per 100 people. So for every 100 people, we're talking about countries that have between 25 and 30. So again, the strategy I suggest you take for reading histograms is to figure out what one bar says, and then base your understanding of the whole histogram on how that one bar works out. So this bar says that and I don't know what that would be, about 35 maybe? About 35 countries have between 10 and 15 guns for every 100 people. So it's not saying how many guns total or how many people total or anything. It's a rate based on how many people you have in the country. So now that we've kind of identified what this histogram is telling us, we can describe its shape. There's one mode. So the vast majority of countries have between 0 and 5 guns per 100 people. At 0 to 5 guns per 100. The plot is skewed right. So we're really falling off from the right-hand side. I mean, you can't really have negative guns per 100 people, but so there's no room to be over here. But this is the height, and then so this is where all the data's at, and then there's just these couple data points that are kind of pulling the rest of the data off to the right. And there are outliers. I would say there's at least 3. There are at least 3 outliers. So here, what we've done over here is offer some rhetoric that describes visually what's going on. There are 3, and we might want to say what kind of outliers are. Outliers, 1 in the 45, one between 50 and 55, 60 and 65, and 120 and 125. So we don't know the exact number of guns per 100 people, but one country has between 50 and 55, one has between 60 and 65, and another country has between 120 and 125 guns per 100 people. And you can ask yourself what that means. And guess which country that is. So let's look at 2 more examples. We have on this histogram the area of garage in square feet for some homes sold in Ames, Iowa. And again, on the vertical, we're just counting frequency. That's always what's on the vertical on a histogram. And then this area is measured in square feet. So again, grab one bar and ask yourself what it means. I'm just going to grab that one right there because it seems good enough. About 200 garages were between 300 and 350 square feet. So you read one bar and you kind of get a feel for what the whole graph is telling you. And here we have 2 modes. 2 modes are present. Well, let's see, we got one between 250 and 300, another between 450 and 500. And modes are interesting because, oh, well, first let's note, I'm calling this a mode even though it's definitely not the highest bar, but relatively it's high. On its right and left, it has much lower values. So this is a relative peak. The modes is about a relative height, not absolute height. So even though this bar right here, we'll just color in green on the top, is higher than what I'm calling the mode on the left, it's not a mode because it doesn't have relative prominence. Modes are about like locally, there's something extreme happening right there. And there's usually a story behind it. Here we have area of garages. Why might there be two modes? Why might there be a lot of garages in this range and a lot of garages in this range? Then also you can kind of see there's almost another resurgence over here. Like it doesn't fall off really fast like you might expect. And why might that be? Is because garages store cars and cars are in discrete increments. So this is probably a 1-car garage versus a 2-car garage kind of thing. 1-car garage. 2-car. And so then you might have like 3-car garages or something more big than that. But so there's reason behind why this distribution would look this way. And sometimes you think about it ahead of time, and other times once you see the picture, you can go back and ask yourself, oh, or you can explain to yourself, oh, that makes sense. This is going to be skewed right again. Because you have these stragglers over here that are really kind of pulling the whole picture off into the right. And there may be some outliers. I mean, you might call those ones at the end. Maybe you can call these others. Maybe some outliers. Out beyond 1,300 square feet. 1,200 square feet. That's a reasonable size for a garage. No, it's not. All right, and let's see. This mean work travel time is our last histogram. You can see it's got one mode at around 24 minutes, around 22 minutes maybe, at around 22 minutes. It's symmetric, so not skewed, and there's not really any outliers. No real outliers. I mean, and this is a bit subjective. You might say a travel time of 44 minutes or 2 minutes is extreme, but there's kind of continuous touching into the full picture. We'll get into a more exact way to discuss outliers in the future. So this is a bit subjective. We can write that. A bit subjective. Okay, but this video is just about discussing visual characteristics of histograms. See you next time.